Hello, I'd like to demonstrate the cloud chamber. This is a device that allows us to see the trail of particles such as alpha particles and beta particles, particles of radioactivity. We can actually see the trail that they leave as those particles pass through this supersaturated alcohol vapor in the cloud chamber. Much like when an airplane flies overhead, sometimes we see the trail it leaves. We're seeing the trail of these particles as they ionize the alcohol vapor, and a trail of droplets forms on that trail of ions. Now, like the Geiger counter, we can use this cloud chamber to detect the presence of radioactivity. Only this will enable us to actually see the tracks of the particles. What we have here is some ice water that circulates through here to cool this down to get the alcohol all ready to condense. The alcohol vapor in this chamber is ready to condense. When a particle goes through, it causes that condensation to take place, so we actually see the trail of the particles. Now I'd like to have the camera come down and take a close look from above and actually look down and see those tracks. So now we have the cloud chamber here, and inside the cloud chamber, down near the bottom of this rod here, about 3 inches deep, we have a source of lead-210, the daughters of which emit the alpha particles. The alpha particles then leave the end of that needle down there, and they leave these tracks that we're seeing. Now, if we could take a closer look at the particle tracks, and we see the trails left by these alpha particles as they leave, one at a time, from the radioactive source. Radioactivity is actually a random process, and here we have quite a high rate of particles being detected from this, but in each case it's one particle at a time that leaves those nuclei that are radioactive and decay by alpha emission. Radioactivity and the cloud chamber.